ma'am. So, ma'am, over to you now.
Thank you, ma'am. Thanks a lot.
Yeah.
So I'm sure all the participants are ready for this. Correct.
Ma'am, you have a
I'm
sharing
sharing.
slides. Yeah.
Yes, yes, yes. I'm sharing my screen. But ma'am, host disable participant screen sharing. So kindly give me rights to share my screen.
अभी इसी वाइफ का नाम होता है। अब मैं कह दूं कि टीवी में क्या इस वाइफ का कंट्रीब्यूशन है,
Ma'am,
बोलो
kindly
कि
check
तो
now.
नाम होगा प्रोजेक्ट सी।
I
अगर ये इसको रिपोर्ट कर दूं तो क्या कर लोगे आप? मैं कर सकता हूँ, कर सकता हूँ, नहीं कर सकता हूँ कि इसमें इन्होंने क्या कंट्रीब्यूशन है। अगर मैं उसको कर दूं जनरल ऑफिस को,
Participant, kindly mute yourself.
अच्छा
no, ma'am. Still, it is disabled.
Still, it is disabled. 1 minute.
Yeah.
Done. Ma'am, it's done. Check now.
ये मुझे साइन कर दो। हाँ, yes ma'am, yes ma'am. Now I could be able to share.
Yeah.
Yeah. So first of all, yesterday I think number of the participants they were asking me, ma'am, kindly share book, any e-copy of the book. So I liked this book a lot. Let me minimize this. Right. So I like this book a lot. This one is the multivariate data analysis, and this book has been written by a professor here, whom we are following through the entire high structure question modeling, and Anderson, Blake, and Revin. And here is now you can see what topics has been covered in this topic. All these techniques, multivariate techniques, because this is also one of the multivariate technique. So this is the very good explanation has been given in this book. So let me little bit bigger size, right? So you can see what you mean by variable or independent variable, what is measurement scale, what is metric data, what is non-metric data, how we can collect data on the ordinal scale or interval scale, each and everything. I think I should say that every researcher must read this book on the priority basis. So I would share this book with everyone, because what is the difference? Yesterday I was talking about what is the difference between validity and reliability. So you could understand how you can differentiate between validity and reliability. And other things like G power, statistical power. What do you mean by statistical power? So each and everything. What do you mean by spec size? So you're going to report in your research paper. All these things you will report. Correct. So all these things are multivariate techniques. So I'm sure I'm going to share with you these techniques. So let me once again now we will start. Right. So yesterday I was talking about, today we are doing hands-on practice. So our title is Structured Question Modeling, SAM. And here is, first of all, let me introduce you what particular icons we are going to use and what do you mean by this. So this is a technique of multivariate statistical analysis. And this technique, as I said yesterday also, it is the combination of factor analysis and multiple regression. So SEM means, it is the definition of the SEM means CFA. CFA, it is a measurement model, and then the path analysis, that is structural model. We will do both these things together today. Then here is the CFA. What could be the measurement model? What we can call it confirmatory factor analysis. As I said earlier also, you can go through either factor analysis or first is factor analysis, then confirmatory factor analysis. But it is not necessary in every case if you are taking validated data. So confirmatory factor analysis only required, no factor EFA, right? Exploratory factor analysis not required at all. Right. So SAM and CFA can redesign the model and compare with the older model if older model is not good fit, both these things. And what are the softwares available in the market? You can say Amos, that is the IBM Amos, right? Lisrel, Statistica, and as well as you can do this structure question modeling with the help of R Studio also, right? In the R Studio, you can because just some set of the commands coding is required, and you can run this structure question modeling in this software. Then the applications of the SAM is to test complex relationships simultaneously, because that was the question arises. Why we people are going for this structure equation modeling, not a simple regression? Just because of this, because all these complex relationships we can check through SAM that cannot be possible in simple multiple regression. So this is the difference. That is why we are using, and several regression analysis of factors simultaneously can be operational in a one single model. Now, first of all, let me just define you all those things. Observed variable, statement, items, we will define in the rectangle box. We are using rectangle box. Latent variables, or yesterday I think someone has asked this question also. Ma'am, construct of factors can be interchangeable. Yes, I said yesterday also. Yes, this is the synonym, right? We are using for the same thing. We can call it as a latent variable, or we can call it factors, or we can call it construct. But all these names are same. So that always we are representing in the oval shape, or that would be in the round shape. But observed variables, always you are going to define, we can call it observed variable, we can call it a statement, we can call it items, all are synonym. We can use, these are interchangeable, right, for this structure question modeling. Always we are using in the rectangle. Then is dependent variable and independent variable. So we are using DV and IVs, right? Dependent variable here is endogenous variables where arrow and, right, where is arrow will finish, arrow will and IVs from where arrow will begin, originate this arrow, that is known as independent variable. So I'm sure if we are using term exogenous variables and endogenous variables, so that means these terms are clear to you. Amos does not work on time series data. Why? That is also our biggest question. Why Amos does not work on time series data? Because, and it works on cross-sectional data. See, always you must understand time series data, that is a single subject we are collecting at the multiple time intervals, right? For example, if I would like to check FDI since 1991 or after 2001 or after Corona, that is our time series data. Means I am just looking after only one thing, that is I want to check this one is the yearly data I am collecting. So single subject at the multiple time, that is why we are calling it time series data. So that is why this structure question model is not working. I mean, Amos will not work on the this one is the time series data. But cross-sectional data, you can understand, consists of the observation of many subjects at the same point in time. So that is why we are using cross-sectional data for this time. So SEM equal to CFA plus regression plus, or we can call it path analysis. So what you have to do, I'm sure you have already collected your data at the Likert scale. After collecting data on Likert scale before applying regression, check, reliability, and validity, it's working on linear relationship. No single statement construct is required. Data should be normally distributed. It's not taking categorical variable. Categorical variable means we are talking about those, there is the category. Category here is, you can understand, there are two kinds of category, right? For example, if we will talk about categorical data, let's say male and female, that is a categorical data. Are you married or unmarried? That is a categorical data, right? Only there are two categories. Where is the categories? That means we are calling it categorical data. So categorical variables you can use as a moderator, right? But you can use not for this one, the structure question modeling, entire path analysis, it would not be able to run. So for this purpose, you will use only this one is the linear relationship, as I said, and no single statement construct required, right? हमें ऐसा कोई कंस्ट्रक्ट नहीं चाहिए where you are using only one single statement. It will not be feasible. We cannot run structure quotient model. And as well as one more important thing, data should be normally distributed. Data should not be abnormally distributed. If data is not normally distributed, you cannot run this system because otherwise your results would not be up to the. So minimum sample size, how you are going to know minimum sample size? So minimum sample size with the help of the KMO, that should be greater than 0.6, then data is okay. Means your sample size is okay. So first of all, whatever is your data, I will show you all those things. Minimum sample size is 0.6, so that data is okay. You will run and the SPSS, you will run this data, and after that you should know this KMO, and that could be greater than 0.6. So, and minimum sample size number of these statements, right? That should be the 5 size. But the means, though, let's say minimum. I'm talking about minimum. Let's say you have 25 statements. So 25 statements multiplied by 5. Right. So minimum is 125 is required. So generally, professor has said is 10 to 20. So DV must have an error term, and definitely wherever you have this one is the dependent variable, that would have error term positively. None of the circle can exist on canvas without a box. It's not possible a simple circle you are creating and without supporting a box. That means we are talking about circle means unobserved variable, and that is not supported by any item. So canvas without a box, it is not possible. And regression weight should be 1. I will tell you why you require regression weight 1. I will give you this answer. So one construct minimum should have 3 statements. So number of times our research scholars are asking, ma'am, how many statements should be supported with the one construct? So that would be minimum 3 statements are required. Right. And all those things I had already defined. Here is we will start after that. Here is difference between EFA exploratory factor analysis and CFA confirmatory factor analysis. Factors are predetermined and then structure is confirmed through CFA. But that means you have taken these factors from a validated questionnaire or through past published publication, through the past published paper. So now you are using. But EFA, if your instrument has never been explored before, you are first time exploring this particular instrument. So then you need to go for EFA. And the aim of CFA is to confirm to what extent our model fits the data, right? It's simply how we will find out all the validity, distribuent validity, construct validity, each and everything we will understand. A CFA is computed to investigate how well the hypothesized factor structure fits with the data. The fit test seeks to find a non-significant result indicating good fit of the data, right? And CFA is a part of larger analysis framework called structure equation modeling, which combines CFA with the path analysis, means regression slope. These things we will work together, right? And now I am just opening my Amos, right? So you could be able to see this is the file. I just want to where we have to reach. You can see this is our data, and you can run this data. You can find out all these values. This is our final path analysis. And this one is we have done the CFA and all these things, right? We can run this, and now you can see whatever, I mean, this one is the standardized estimates of all these constructs. Fine. So first of all, we would understand how we can go through. First of all, let me open a new file. Right. Now you can see. First of all, we would understand all these icons. What is the meaning of all these icons? See, if this icon is active, but this icon is not active, you can see these are not active icons. Why? Because this is known as canvas. This is known as canvas. And canvas, you can see this is the A4 size canvas, and that is the portrait. Now, let's say I am just drawing here. This is my box. This is the rectangle. Rectangle, you understand, means we are talking about items. Correct. And what is this circle? That is unobserved variables. First of all, whatever you are going to select, after that, you are going to deselect. Let's say, if I have selected this, so this is the box I can prepare. But if I will not deselect first, until unless I will not deselect, I could not be able to select this oval shape. That means those are my unobserved variables. So let me deselect this, then I would select this, and now I'm going to create this is the variable. Right. See, I'm just removing this. First of all, now you can see the difference. Right. Earlier it was, these were disabled. A moment I had created this oval shaped structure, and now you can see these are able. And let me one more, or what you can do. Now, let's say I'm just creating, I will show you how you can create it. Hold on. Right. Now, what will be happen? These are the arrows, right? You will create all these things. Arrows always unobserved variables towards the observed. See. So this is the magic stick, and magic stick, you can put it here, right? You can put it here. So all the arrows automatically, these arrows are reaching. Now, what we have to do, let's say, first of all, we will resize all these rectangles. So how this, suppose this is the 1, 2, 3, 4th, at the 4th place. This is the single finger. So that means we are talking about only one object. That is written here already. Suppose I just want to show you. Let's say you're just clicking, select one object at a time. So suppose I want to select one object at a time, let's say this object, right? This object, and select one object. And now I want to move. You can see this is the small trail, right? That means we can move. We can move. Single objects are moving, but along with it's not moving. Now you can see why? Just a moment. Whole, it is moving because you can say this is the tree-like structure. And when we will deselect this, now only one single is moving. Now you can see one single, not entire structure is moving. But when we will select this, entire structure is moving. Now you can see, right? Now here is, if we will, let's say we will copy this image. You can say this one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninth item in the first column, right? If we will select this, right? First deselect this, and now select this, right? So now we had copied, and let me open one of the simplest, let me open this Word document, let's say. And I just want to copy this, let's say Control V. Now you can see. This is the difference. If your any diagram that is out of the canvas, that you cannot copy it, because this is our active canvas. So what should I do? For this purpose, I will just go there in view. You can see file. If you want to open any new file, you have to click here, right? Save as, each and everything. That is all existing file. So you have to, wherever it is, put it in any folder. You will click here. And after that, now there is edit, means you want to copy, paste, select all, deselect. You can see meaning of all these icons are here. Select single item, select all. You will choose this one. Select all means this one. I will show you. And deselect all objects. You will click here, right? And here is duplicate the object, moving. That is, if you want to remove any object, right? Resize your object. Let's say I'm selecting this and I want to resize, right? Resize, let's say I want to put it like that. So resize, but suppose resize you want to do of all the together, then you will select this. Otherwise, if suppose now you are resizing, so only one object would be, let's say I'm selecting. So let's say, so only this object I can resize, not other, because I have not chosen at the time of this one is this is a tree-like structure. Why? Because that would be selecting all the items together, right? Up now, we have seen on this Word document, you can see here is only half of the picture is copied. So what should I do? That is this is my canvas. I will go there in my view, interface properties. Here is, you can say, portrait letters. So I will select it, landscape A4. A movement I would apply. Right now you can see this is on the canvas. This is on the canvas. Up now, again, we will do the same practice. And here is, we will select, we will copy this. We will go to this Word document. And here is now, let's say, here is, I want to paste it. When I paste it, now you can see there is the complete picture. That was the incomplete picture, and that is the complete picture. So I'm sure you understand what do you mean by this one is the canvas. So on the canvas, whatever is the you had put it, right? And everything you will paste here. I mean, what is the canvas? That would be, you can copy and paste. Otherwise, rest of the outside this canvas, it is not possible. Right? Fine. Now what we have to do, let's say I want to, now first of all, please save your file. This file, new file I had opened. So I will save as, and where do you want to save as? Let's say I would like to put it in this folder only, 19 June 2023, because this same data I'm going to use it. So I'm giving, let's say, today's what date? Today is 15th March session. I would save, so I could recall it, and I have saved this file. Now you can see movement you had saved, that is appearing here, 15th March session. Why it is on the top? Because in your file, first is numbers, then alphabet. And machine is always working on the numbers. So wherever you are giving numbers, 01, 02, 03, that would be on the topmost. Right. And rest is files doesn't have any number. So that is why these file names are below those. Right. So I'm sure, first of all, we had saved this file. Now, this is the save sign. You have to click here, then you have to save this file. Correct. Now, I just want to see what other parameters I have taken. Let's say this is the 1, 2, 3, 4, 5. In my, I just want to show you first of all file also, right? Rather than directly we are going there, right? So let me open my file. In this folder only, the material. File is here. Right, this is the file on which I will work. So first of all, let me show you what are the components in this file. Then you can understand. OC and EP. That is will open in the, because this is my SPSS file. So that will open. First of all, how you are going to define, that's most important. Meanwhile, it is opening. Yes. Now it's open. You can see total, because I have 5 constructs. So first construct is defined by C1, C2, and C3. These are the items. Second construct, IN1, IN2, IN3. Third construct, AD1, AD2, AD3. Then M1, MI1, MI2, MI3. Third construct, EP1, EP2, EP3. And then further is, there is the, if suppose we have fourth item also, then EC4. I will show you when we are going to include fourth item. So what are the, how the results are poor or results are improving. So now how we can define in our SPSS, that's most important. So you can see, first of all, in SPSS, you are going to define all these variables. Let's say my, not variables, these are my items, right? C1, C2, C3. This is defining my first construct. So now this is the numeric. You will define here. Decimal, I don't want any decimal. You can put it 0. Otherwise, that is by default, that is 2. So I will put it as 0. And values you are going to define. Let me show you values. How you can put it values. I will just delete all these values. First of all, 1, 2, strongly disagree, because seventh Likert scale I have used. Let me show you how you can define all these values here. 1, 2, 3, 4, 5. Strongly disagree, 1 we had given. Mostly disagree, 2. Disagree, 3. Right? And that is the neutral, agree, mostly agree, strongly agree. So let me remove all these variables. I would select Control A, or otherwise remove one by one. I'm removing all these, let's say, disagree that you can understand. Now, value I'm giving, let's say 1. First of all, I will give you 2. Then label is mostly, I'm giving mostly disagree. Disagree. Mostly disagree. Mostly disagree, right? So shall we now add? Add. A moment I had added, you can say mostly disagree. Now the first one is, I would like to define it as strongly disagree. Strongly disagree. Strongly disagree. Otherwise, you cannot run your file in your structure question model. So now you can see, once we have done, right? So, okay. So you can see here, these are the strongly disagree, mostly disagree, neutral. I think neutral spelling is wrong. So I'm just correcting it. I will just remove it. And value is 4. And I will say neutral. Right. Now it's all right. Okay. Wait, okay, fine. First of all, add. Right. Okay. Now, what we can do, let's say now the again, other parameters also you have collected on the same parameter. So what I will do, let's say I'm removing all these things, all these values, right? I'm removing. I will show you how you can use shortcuts. And let's say I remove all these values, right? Okay. Now there is none. If you will click here, none value is going to define here. Now, what we have to do, simply go there, right? Simply go there, right? And what you can do, you can collect all the values, right? Simply. Here is, you can right click, copy, and here is, you can paste. Right? You can copy and paste. And the same manner, you want to, let's say, I'm copying here, and I want to paste in a one go at all the places, simply I will paste it. Now you can see. So all the values are here. And here is scale measurement, because there is as I said earlier, before that, nominal, ordinal, or scale. That would work on scale data, right? Because nominal, that means you are assigning any number to anyone. Like Mr. Dhoni, he usually wear 9 number t-shirt when he is playing in the cricket match. So it doesn't mean that he's a ninth number player. It means he is just a number is assigned to Mr. Dhoni, right? It is just a number. 9 is a number. So that is a nominal. Is this? So scale we will select, and scale we are going to select for every my item. So I'm sure this part is clear. So you would be able to feed your data accordingly. Fine. Now what we have to do, we will save this file first of all. Yeah, we will save this file. And we will minimize this output. I don't want any output of SPSS. So first of all, what we have to do, first of all, we will create, because we would like to create similar kind of This one is the similar structure for the CFA. These are three constructs: CON, INT, ADP, MIS, and EP. And these are items, those are supporting these constructs. Because this construct is defined by C1, C2, C3. This construct is defined by IN1, IN2, IN3. This construct ADP is defined by AD1, AD2, AD3. And MIS, this is defined by MI3, MI2, and so on. Right? So we will prepare the same structure. And this is mine. Right? Fine. So what I'm doing, if I don't want to add fresh, we will do, I don't want this structure because, let's see. So we will deselect it. What happened is we will deselect it. Right. I said until unless we are not preparing any structure, that would, yeah. So what we can do now, we will deselect it, right? Because similar kind of boxes you require. So simply what you have to do, you will click here and you can copy. So all the boxes will be saved. Right. Let's say, first of all, I don't want to this one. Okay, all the constructs having three items. Now we will click here and now you can see this is the box we had. I don't want this one. So that will be selected. Now the arrows required and we will put an arrow on these three arrows. Right. And we will use this magic strip and now we want to we want to rotate them, right? And we can resize them also. Not resize. I should start. I mean, moving from one place to another place. You can see. But if suppose I don't want to entire second because that is the gap is bigger as comparatively to this. So I want to move only this one box. Right. So now it looks better. Now, what we have to do is simple. Up now we will press here because otherwise it will take time if we are creating one by one all the boxes, we are creating once again all these things and all. So what I will do, first of all, I would like to give error term because every item is required error term. So this is my error term and I can resize this. You can see. Now it looks better. And I would like to increase the size of this circle. Great. And same thing, I don't want to again and again, right? And this one is error term. I would like to give it. And same thing, because three error terms are required. And now I would resize this. Now, so first of all, let me, because whole I have selected. So individual, I want to move it. Right. And now I can reselect this. I can resize this a little bit. At this time, I can select this. And now I can resize this. So all three together. Right. Now it looks better. So now what we have to do, simply we will select entire structure and we want to copy this. And now you can see 2, 3, 4, and up now. Now you can see these are not fitting in this. Will deselect it. Not fitted in this on this page. So what I will do, there's the two ways, either one by one, I can fit into this page or what I can do here is I will click here. You can see this one is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one is the 12th one. I had click here. A moment I had clicked here, now you can see these are already put on in the single, right? I mean, that is visible also. Now what we have to do, because all these are my constructs, so there should be covariance also. So this connecting arrow also I require. So simply I will put it here. These connecting arrows. Right. That is the connection, because but all constructs should be connected to each other. So again, this is connected to this one, but this is not connected to this one. So I will put it one more arrow that is connected here. This is connected not from this one, so I will put it here. I will give you shortcut also of this. But first of all, you must understand how we are doing in a proper manner. So here is, this one is connected to, but this one is not connected. This one is the construct is connected to this construct, and this is connected to this construct, but this is not connected to another two. So we will right. Now you can check all the, because if suppose you have not checked, no issue. And from this magic stick, right. Now it is more looking more presentative. And now what we have to do, here are, you can see title. You can give title for this page, and here are variables. It is empty now because I have not loaded any file, and that is also not visible, right? Because when you will click here, that will show you list of variables and models. In your model, how many variables are there? And here is when your list of variables in your data set. How many variables in your data set? Whatever is the file you are going to upload. Correct. So how we are uploading this file? You will click here. Here is below this. This is the table kind of structure. And we can give the number also 1, 2, 3, 4, 5, 6, 7, 8, right? 8. First column and the 8th. So the left hand side. You can see. Sometimes we can give the numbers also A, B, C, D, right? Or 1, 2, 3 and A, B, C, D. And after that we can give A, 1, 2, 3, 4, 5, 6, 7, 8. So A8 we are using, right? So suppose I want this file. Which file? File name. This is the my file, OCNEP, right? I have shown you this file. I will open this file. And after opening this file, then I will press OK. Right. Then here is, here is, you can find out what could be the estimations you required, right? What would be your output? This is the output side. So minimization history I require, and standardized estimates also I required. So I will click here, standardized estimates, and whatever the other things are required, residual movements and all these things you can select. Great. Then after that, what you have to do here is, now the moment you had loaded this file. So now you can see these are the variables. It would be in your data set that is visible, right? Because this is empty. Why? Until unless you will not load all these data in this model, it will be empty. A moment you will upload, right? So let's say drag and drop C1 right here. Now you can see in this box, middle one, C1 is reflected. Earlier it was empty. Now C2, let's say I have dragged it. Now C. Correct? Then after that, IN1, IN2, IN3. Dragged it. Then third one is mine is 81, then 82, then 83. Then further is MI1, MI2, and MI3. Right. And what is my last one is EP1, EP2, and okay. You can see now all the variables, those are available. That is showing all variables available in your data set, in your file, in your Excel sheet. But here is, you can see this one is reflecting only those variables, those you are using in your model. This is the difference, right? So I'm just closing this. Oh, this one. Now I want to give, now again, I would like to save this one. Is now you can see uh, path analysis. Now I would like to give name of this UN, INT, ADP, MIS, and EP. Let's say, so simply I will use CUNINT, right? So I'm just giving it, let's say, whatever name you want to give. So you will click here, and now you can type here, let's say, CUN, you had given, and I would like to give, let's say, INT, all right. That is, I would like to give ATM, and I want to give name for this. You can keep on changing. Let's say, I just want to show you MI, let's say A, we are giving, because that would be related to your variable, whatever is the variable is defining. So, and now you have to, don't close it again and again. You can click here. So now it's, right, now it's empty. So that is, we can say EPA, for example, we have given, right? So now all these names are visible here. Correct. Now suppose I am selecting this and I want to move little bit. This one is, I want to little bit noise, right? And we can reduce the gap of this also. Right. It was gap. Right. Just sorry for interruption. That was an important thing. Yes. So what we have to do now, we would deselect it. And now because regression weight is required, right? So we will click on any of the arrow, right? We will click on any arrow. And now you can see text parameters. Here is, you will give at least on one arrow, one regression weight is required, right? And on this second arrow, again, regression weight 1 we will give. And again on this regression weight 1, because minimum, otherwise it will not run. I will show you what kind of the problem you can face after that. Yes. Now we had assigned at least one regression weight on one single. So now we had selected file also. Now this structure is properly given, right? And now we want to give error term name also. So simply you will see what here. Again, I'm repeating stuff. Here is on these circles, you will click here and text. You will click here text. What could be your variable name? Let's say I want to give E1, right? E1 is reflecting here. Then is I want to give E2. This is the error term, that would be E3, right? No error term should be similar. So that would be E3. Then we will click here E4. Then we will click here E5. Then further is E6, then E7, E8. Other way also to define all these parameters. E9, then is E10, then further is E11, further is E12, E13, E, I think 1, 2, 3, there's the mistake. Because that would be E4. E4, and this one is the E5, and that would be E6, and that would be E7. Otherwise, E15 also you can give, but in a sequence that would be better. E7, then E8, and E9. Then further is E10, E11, and E12, E13, E14, and E15. All the error terms we have defined. Now, you can see somewhere these names, those you have defined, these are outside these boxes, right? So here is, you can say font size you can reduce. Let's say here the font size is 18. So that is where, okay, minimum is right. We can give font size, let's say 40. Now it looks much better. That is much better, right? Same manner, we will reduce all the, now 14 is much better as comparatively to 18. So we have reduced these bonds. Now it looks better. Now what we have to do, you can see everything is ready. Now you can see standardized estimates, minimization history we require as the output. And now we will run the file. See, moment I said run the file, it has given some warnings. What are these? Proceed without the analysis. Second option is cancel the analysis, right? Why? Because Amos will require the following pairs of variable to be uncorrelated, because ADM is not related to EPA. That is, let me check. This is my ADM. This is my ADM. ADM is not correlated with EPA. So that means no arrow is connecting this ADM with EPA. So that is why it is showing this error. So I will press here, cancel my analysis. Right. First of all, I would like to put arrow, whatever is the problem, because each and every construct should be connected to each other. So let me, with the magical strict, I would correct it. Right. Now it is much more better. I will deselect it. And after that, again, now I will run my file. A moment I said run my file is running, and you can see now this is a red arrow. And earlier, before running, if you have some problem in your file, so this arrow will not be active arrow. It will not be turned into red. It would not be activated. And because I need standardized estimates, so I will click here. Now you can see all the values are here. Here is, you can see 0.77, 0.89,
Hello, ma'am. Hello. I'm audible. I'm audible.
You are audible, ma'am.
I think your mom's internet connection is not there. Let me check with her, okay? I think she left the meeting. One minute. Participant Ashulika ma'am has called. Her system got restarted, so she's joining. Kindly be waited for the 2 minutes. Ma'am, kindly check whether you have a this one sharing rights.
Right. I think I could be able to share. Let me check. Yes, I could be able to share.
Okay, thank you, ma'am.
Right. I'm sure my screen is visible. My screen is visible, right? I have not saved, so just because of this, this is blank. All these things, right? So again, I'm giving some numbers to all these boxes. Just a moment. Right. I'm giving quickly these names. INT. I'm sorry, my system actually has restarted. Two heavy files I had opened. Correct. Now the second one is we are giving, not sorry, INT, no INT, com. We have to give CO and com. And this one is we will give INT. And this one is I want to give AD. Let's say ADM. What is the name? This also INT. And next we will click here. So ADM. Next we will click here MI. Let's say MIA. My name. And this one is we would like to give EDA. Right? So all these things, and you can see plugins, right? If suppose you want to draw all the covariances, so you can click here draw covariances. It will do it, right? Name parameters, it will give you, right? If you will click here name parameters, so it will give, right? All the parameters, it will give names. And as well as suppose you want to name unobserved variables, right? It will also give name to the unobserved variables, pattern matrix model, all those things. I mean, resize observed variables, it will do that, right? If you will click here, resize observed variables, it will do. And now again, because we would like to give error term name also. And this time what I will do, I would like to save this, right? First of all, let me save this. Otherwise, I will use it. So I will say E2 and I will say E3. And it isn't just a, because when you are using continuously all those things, so you will be habitual and easily you can do that. There is no problem when you are running this. And then is E6. And further is E7. And further is E8. Then E9. And further is E10. E11. Then is E12. And further is E13. And E14. And further is E15. E15. Right. We're done. And let me save first. Otherwise, it will vanish. Right. So I think file we had already attached. Right. And simply we can check it. What output we required, right? Estimate, this one is the standardized estimates we required. We can do that. And after that, we can run this file. Again, same problem it is reflecting. That was reflecting last time. ADM is not connected with APA. So cancel the analysis. And first of all, let me take this two-side arrow and I would connect APA with EPA. And let me, with the magic stick, I would correct it, right? It looks more beautiful. And then further is I would run my file. A moment I will click run my file, you can see all these 371 cases, all these summary is here, default model minimization, all the results are here. Right. And I will, what happened? This button is still not active because standardized estimates I require. I don't know what happened. Oh, see, that's what I was saying. This problem you have to face because you had not given regression weight to on any error. That is why my this red button is still is inactive. Right. So what we have to do, that is why I was thinking I have run my file. File is running. File, there is no issue with file, but there is the issue with the model. So that is why I said you have to give regression weight on at least one arrow that is connected to your items. So you have to give text. We will go there. One. The same way you have to give regression weight. Same way you are writing one, you are writing one, and you are writing. Let's say middle arrow we had given. Now I think model is complete. So let me run. Now this red button is active. Right? Red button is active and I will click here. Now you can see all the values. 0.61, 0.43, 0.40. Let me save first. Right. A moment I will save it, right? So that values would be disappear. Again, I will click here. So now values will be appear. So now this is our CFA. CFA means we will talk about points. You can see these values, right? Let me see. If your values are here. You cannot move any icon, this one is the construct or any items until unless you will deactivate this red button, right? So now we can see 0.77, 0.89, 0.69, all the values are good because I had already said yesterday in my session, these values should be greater than 0.5, 0.6. I could say 0.6. Means these items are able to define this construct. Because on is a construct, int is a construct, ADM is construct, MI is construct, EPA is a construct. I think till here there is no issue, and we will address some question answer session also later. So here is all these values are, you can see, pretty good. 0.77, 0.89, 0.69, 0.83, 0.84, 0.77, 0.72, 0.81, 0.77. All the values are above 0.6. Nothing is less than 6. If there is less than 5, less than 0.5 or less than 0.6, that means this item could not be able to define your constraint. Right? That is a very weak item that is related to your constraint. Now we will talk about all these things, correlation between all these constructs, because these values are correlation between all these constructs. So now you can see, this one is the con is correlated with the int, but that is, here is the thumb rule is all these values should be less than 0.5. But you can see this value is less than 0.5, this value is 0.5, 0.5, but this value is 0.61. That means there is some problem in my data. This value is 0.63, but somehow we can accept if it's nearby 0.58, 0.78, 0.7. That means this one, int is highly correlated with EPA. So we would find out what is the issue in this data. Otherwise, what we can do, we can merge, because these are highly correlated. So we can merge both the construct into one. Right. Otherwise, there will be multipolarity issue will be arises, because 0.78 is the high correlation that is leading towards the one. So that means there is the multipolarity issue will be existing. Right. Now we would like to see whether the validity is correct or not. So for this purpose, what we have to do? Next step, we will go there. We will click here. Right. A moment you will click here, these results will open. All these analysis will open. Estimates. Now you can see all the regression weights, significance level, right? With con C1, with con 0, all are significant. You can see. Right. And these are the standardized regression weights. All those things, values, those are on the arrow. You can see, same values are here. Then further is covariance, then further is correlation, then variance is enough. Now how we can say this model or this is the CFA, that is the correct one, right? So let me minimize this. And here is what I will do. Let me open my stats wiki. Right. See. What you will do, simply you will type here, and that table also I will share. Otherwise, you will type here stats wiki, right? You can see stats wiki. Stats wiki by Gaskination, because Professor Gaskin has given this particular tool in which directly you will paste your data and you can get the results. So this is the stats tool package, right? You will simply type here stats wiki, right? And you will reach on this page, and the moment you will find this Excel sign and stats tools package. You will click here. When you will click here, then you will find out, I think that will be the Excel sheet, because I have used long back. So this is the package through which you can use this Excel sheet. Otherwise, I'm going to share this Excel tool. That is clearly defined here. You may find this set of Excel tools useful, necessary for many of the analysis. You will learn about this stats wiki tool package. So you have to just go to this and you will find it here and video tutorial also you can see this is the for the Amos and SPSS. So that will tell you how you are going to use this. But here is I'm going to use directly. I would like to show you this package, how you're going to use. This one is the materials and this one is you can say stats tool package. I had already downloaded. I will click here. Now I will show you how you can check validity. So I would like to close this, not required at all. No, remove this. Okay. So I will go there, validity master. So you can see paste correlation table in A2 and paste standardized regression weight table in F2. Right. So what I will do, I will go to my results. First is correlation it is required. You can see that is the correlation. Right. And I will click here and I will copy this and I will paste in my this particular area. So I will paste it. You can see my correlation group 1 that is pasted. Here is it's asking paste standardization regression weight table in F2. So what I will do, I will go there, standardized regression weights where it is this one. Standardized regression weights. I will click here and I will copy and I will click here and I will paste it here. So now you can see both these things are available, correlation and standardized regression weight and read. I will click here on this red button sign. Now you can see this is no validity concern. Wow means if that is wrong. So these would be means if these are your, this one is the data is not confirming all the validity. So maybe possible these are red one. And that would be from the red color, right? It would be reflected. But in my data set, there is all the values are good, all the no validity concern in my data. So simply what I will do, I will just copy and paste in my Word document. I will do that. Let's say any Word document we can open. Let's say SEM questions. We can open the SEM questions. That is opening. Close this. Okay. Enable editing. And I would like to answer all these questions to you. Right. And little bit size we can do bigger. At the end, we can paste it. While I'm doing this step, I will tell you what is the reason behind this. Control view. Right. So this table it is, I had pasted and I will report because just a moment, I would like to open my paper also. This was the paper yesterday we have discussed and some more papers I will discuss. So I'm just opening this paper. Right. And now you can see where I had reported in this paper and the same paper, Journal of Financial Services Marketing. Now you can see in this paper, I think in this paper, I have not reported directly. I have reported here in that manner. Let's see. What is your CR value? And here is measurement, not this one is AV value, composite reliability, and Cronbach alpha. Right. This is the CR, composite reliability, AV average variance extracted because we have got through this table. So we are going to report standardized regression weights are there. Standard. This one is the squared multiple correlation, right? That we had copied in the stats wiki. And the same thing, and through which we have got AV, this one is the composite reliability, etc. Right. Now, after that, what we have to do, you can see here, you have done because all the validity issues you had cleared. Now we will go to model fit. A moment C. Earlier we were on this, we had clicked here, estimates. And now we have gone to model fit. And model fit, now you can see. C-min that is divided by degree of freedom, that is 2.321. And what is my paper is saying? You can see this is it. Model fit indices, you can see chi-square and oblique degree of freedom. That should be, right, greater than 3 and less than 5. That is acceptable. So 3.675, that is acceptable. And in my case, what is happening? That is 2.32. But it is acceptable because somewhere is the, because I have seen some other statistician, they said above 2, it is also acceptable. So in this case, that is the Siemens 2.32, 321. Then further is, if we will talk about, here is GFI 0.935, AGFI 0.902, right? And you can see, and same tables, you can, that is, suppose you want to select this and you can simply copy and you can report to your Word document wherever you are writing your paper. So suppose I want this Siemens table that is required here. So I had put it here, the Siemens value, right? And further is, if I will go to all the results, you can find it. This one is the your NFI, that is 0.945, and your CFI 0.96, that is above, because all these are good indexes. So here is, this one is the parsimony adjusted measures, right? And further is, that is the bad indicators. RMCEA, that should always be below, right? So that is 0.060, right? This table also you will select it and you can copy. I mean, those are the most important parameters required to report in the paper that we have copied. So this one is RMSEA, that is 0.06. So let me go there, my paper, where I had reported all those things. You can see that. Model fit indices, chi-square 3.6, CFI 0.99, great, GFI, that should be, these are the threshold limits. So in between, you are going to show threshold limits, and after that, you are giving your values. Then after that, observation from the result, then you will cross-check whether your values, those are the measurement model, you have received these values, these are correct or these are not correct. So CFI, you can see 0.99, that is great. GFI 0.95, that is great. NFI 0.95, great. AGFI 0.80, RMCA, that is, it should be. If it is less than 0.05, it is good. If it is 0.05 to 0.10, moderate. So in my case, that is moderate. And if it is greater than 0.1, so that is bad. So means that should be a very less. And after that, what you are going to do, you will report here all these things in the text also. That is related to our after EFA, then CFA. This table we had created, you could understand. From there, we had created this CFA table. And after that, we have gone through, see, all these things you will define here because root mean square error of approximation, RMSEA, according to this particular Hume and Bentler in 1998 must be equal to or lower than 0.08 for an adequate model fit. So I'm sure in my data, in my results, you could find it, that is adequate model fit because that is below 0.80. In my case, RMCA value is 0.060. Correct. And then further is results obtained from the CFA are given in table 4, and this is our table 4, right? All the values we had mentioned here, which shows all the model fit indices are as per their acceptable range because all are acceptable, great and all. The root mean square error of approximation, RMCA, measures how well the population covariance matrix would be fitted by the model with the unknown and carefully specified parameters estimate. Correct? Then further is an upper limit of 0.07, strict cutoff value of 0.06 as per this author. We have cited this author. Here this indicates a good fit, right? And measurement, and means if I had given this citation, means not only I am saying, other authors also saying that is the same thing. So, and measurement model provides a strong match for the sample data as shown in the RMC, right? And table 4 and table 6, that is reflecting chi-square value. So these are the further CR, composite reliability, and all these things you had reported here. But you can see now we have not done yet structure equation model of the internet banking adoption, right? I mean, for this, now I will apply the same thing on my data, right? So what we have to do now, now suppose you want to copy this entire thing. So simply copy this. You will click here, copy this, and you can report to your here in your Word document and simply control V. And this one is the picture that is copied on the Word document. Right. And let's say we want to create, a model path analysis. Path analysis, let's say, first of all, I would save this. And path analysis, let's say, I want to do this path analysis. Right. So how you are going to create this? That's important. So simply same file you can use it. This one is the 15th March. I have saved this file. So I would use this same file, but you will save as by the other name. So what I will do? Let's say I am changing all those things, or otherwise you can open a new further, I could say new page. Then after that, you can do that. Let's say, if I will say title, you can give your title also this page. How you are giving the title? Let me show you. It's not working. Right. So suppose I want to use a new template, right? New template is open, right? And what I will do, I will go there on the 15th March, and this one is I will copy this entire, this one is the picture, and I will, paste on this, the new template. I will just control it. Okay. And now you can see this is the picture is here. And now I would, there is deselect all, right? Moment I had deselect all, and I would like to move this entire, the entire group here, right? So again, what I will do, view, and here is interface properties. I would like to put it as a landscape. And I would apply this. So now this model would be like that, and I will fit into page. So it is like this. Right, fit into page a moment I did it. So that is font sizes changed. No shoot. We will revert back. And now what I have to do, let me this entire one, let me that is sorry. That is below canvas. So we will change this. And we can resize also. Yes. See, all these things are. Otherwise, canvas size also we can increase. So there was no need. We are going to increase canvas size also. Right. And canvas size, suppose you want to increase. So I have taken A5, I should take A4. Right. I have taken now it is A4. So what we will do now, the next thing is I would like to create our path analysis. So what we will do, let's say you have selected this one. You have selected this one so that you can rotate, right? Direction can be changed. Suppose this direction you want to change, you can do that, right? And also, but I want to create, let me first save this file. File name is, let me save as, and this is the file name. Let's say I'm giving 15th March, 15th March and final model. Final, final models, right? So I will just save it. A moment I save, so you can see final model, new file has been created. Right. Now, what we have to do, suppose I want to create the same path, right? So EP is my dependent variable and rest of these my independent variables. So all the arrows are going towards this EP because we had already checked all the constructs are validated, right? Through statistically, we have already checked. So now in the final path model, what I will do, this EPA, I will move it, right? So simply what I will do, I will collect it and I will move it, right? That would be like that. And I want to rotate this. Yes, I can rotate this, right? It would be like this, right? And let me deselect it rotation. And after that, I would like to this. So that is like that, right? And further is, I want to move this. This one is, you can see, this is the correct. Correction. And now let me save also. Right. Further is, I want to see this one. So because that is my dependent variable and these are my independent variables. So no correlation is required in between dependent and independent. There should be correlations required, but in between there is no correlation is required. So what should I do here? In the final, I should remove all these arrows. Those are going towards the, I have removed. I have removed, right? And now I need arrow because these are my independent variable and these are my independent variables. Independent variables, these four are independent variables and this is the dependent variable. Now one more thing. Whatever is the dependent variable that require error term, right? So what we have to do, we will put it error term and we will deselect and let me just move this error term, right? It will be like that. And I want to resize this error term, right? So let me, this is good. And because already till 15, we had already given this error term. So first of all, deselect it. That is the biggest issue with the Amos. Whatever you will select. So next time, if you don't want to use it, you are going to deselect it, right? So what we will do here is we will give error term and text is, I would like to give, let's say 15 till 15 we have used. So that would be E16. That's okay. Right. So E16. Now, this model is, right, this model is created. And now what we have to do, simply we will run the file. Where is our file? Let me open my file name. And this is the same file, right? We have used for this ECFA, right? And let me open this file. And further is what we want because standardized estimates we require output, right? And I have selected. Then finally, what we have to do, we will run this file. Right. A moment I have run this file, you can say this button is active, right? And now I will click here. Now you can see. Now you can see all the values are, these are good. These values are 0.05, right? There is the 0.49 minus 0.05, 0.47 and all. So this is my, and in that way, what you can do, you can change, you can resize, because that should be beautification. You can do that. And as well as you can again and again you can cross check whether how the moderator will work over here, what could be the moderator, how we can use mediation, moderation, each and everything. Model A, you can give the name as model 1, model 2, model 3 and so on. So in that way, that is would be reflected. Now I want to see results of this. So let me open these results. Whether this is a model fit is there, yes, you can see here 2.321 and all these things, GFI, AFI and all these things, that is reflecting here. So now the next table, what I have used in my list, that is the structure equation model table that is come from after doing analysis of this. After doing analysis of this model, I have created this. But if I will talk about in my paper, you can see there is this table. It is not for that path analysis structure equation modeling. These are the indices. Here is the measurement model. This is the measurement model, means we are talking about only CFA. So this is the CFA. This thing. So I'm sure you understand how we can use all these things. I'm sure each and everything I had covered. I mean, whatever is the basic thing you required, right? And suppose you have done something, let's say I am opening, and that I will say, right? Let's say this one is the 15th March model. Let's say I had opened, right? And suppose you are choosing some other file, let's say you have some other file and you want to use that file, so you can use another file also, right? Now my basic question is this. The same thing is, let me delete final model. So suppose I want to run this, all these things, and I want to copy this. Here is, I have taken on my clipboard and I would like to paste in my research paper. I can do that. Control V. And this is, I can report it, right? With the beautification, you can do that. And all these values you can report in your filter. Now, my basic question is this. You can see. First of all, people, they will ask you what is regression rate and why. Of course, we have given regression rate here in my CFA. You have seen I had given 1 regression rate. These are my constructs, EAPA, MIA, AGM, INT, and CON, and these are my items. And I had given 1 regression rate. So let me clear about this, why we had given these regression rates. A regression rate is a number that specifies the relationship between two variables in a regression equation. It is also known as the regression coefficient. In a weighted regression, each observation is given a certain weight that tells the software how important it should be in the model. That is why we had given, here is, you can say, why we keep regression rate as 1. Fixing weights to 1 simplifies the comparison between coefficients. All other regression weights for that factor become relative to the fixed one. Like, for example, if we fix the regression coefficient of an observed variable to 1, the latent variable becomes reversed. Suppose our latent variable represents math ability and the observed variable is the number of errors on a test. Fixing the coefficient of 1 ensures comparability and ease of interpretation. That means this model can be comparable and is the maximum regression weight that is required is 1. If there is 0, what would be happen? 0 means, that means there is no correlation among all the variables and there is no further analysis can be possible. That is why we had given regression weight is 1, because regression weight that will be moving from 0 to 1, right? So that is 1. Next is Next, we will talk about what is the difference between standardized and unstandardized estimates. Yes, I would like to show you. Let's say in the same model, let's say I don't want standardized. Let's say I'm talking about these are the standardized values. Now you can see these are my values. If suppose I am choosing unstandardized estimates, so now you can see all these values has been changed. All these values has been changed. Standardized, what is these values? 0.83, 0.84. Now you will see when I am clicking unstandardized, these values are 1.06, 1.99, etc. So what is the meaning behind this? Means why unstandardized regression coefficient and what is standardized regression coefficient? We can call it Z score. Z score is our, because we are converting our data in a some standardized format. Unstandardized, if we will talk about unstandardized coefficients are derived from the raw data. During linear regression modeling, they represent the effect of one unit change in a predictor variable on the response variable. Means if we will change one unit, we will change, so that will reflect in your dependent variable, right? Then is these coefficients are directly interpretable in the original units of measures. For example, we have regression coefficient of this. For the predictor variable, what is our predictor variable? That is age. It means that a 1 year increase in age is associated with the directly that will decrease. Why it will decrease? Why? Because that is sign is minus. So means it is affecting negatively. If there is positive, so that will, this one is, if the 1 year age increase, that would also increase because that is positively attracting. But there is the negative sign, regression coefficient is negative 0.409. That is why it is, that is decreasing. But when we talk about the standardized regression coefficient, so standardized coefficients are obtained by using standardized data. Means usually that is why if there is the error term, right? Let's say your data is giving, yesterday somebody had asked me this question, ma'am, if our RMSEA value that is on the higher side, how we can improve it? So that is the solution. You can calculate. I had already prepared a video on how you are going to calculate Z-score, right? So you can just go through that particular video and you can convert your data into Z-score, right? So first of all, you can standardize your all these values, and after that, maybe you could find out your RMSEA value would be decreased, means towards the 0.5 side or 0.6 side. That is one of the solution. So they express the effect of one standard deviation change in the predictor variable on the response variable. Standardized coefficient allow for direct comparison of the relative importance of different predictors. So now you can see, for example, a one standard deviation increase in age correspond to a 0.09 to standard deviation decrease in house price, assuming square footage is constant, right? Here is, and again, if when to use each, that is also, it's unstandardized coefficient and standardized coefficient. Unstandardized coefficients are useful when you want to understand the impact of a specific unit change in a predictor. But standardized are much more valuable, because that is why we are reporting in our research paper only standardized coefficient rather than unstandardized coefficient. So predictor variables are measured on a different scale, that is age in years versus, see, that would be the same unit as it is required. But here is, might be possible, we are using different scale. For the age, we are measuring in terms of years. Right. And another one is that we are talking about, that one is the another construct we are using as square footage in a square feet. So that means standardized means we are doing standardize all the units at the one standard. So you want to compare the relative influence of predictor regardless of their original units. So that is why generally people are doing their analysis on the standardized coefficient, that is much, much more important as comparatively to the unstandardized coefficient. That would be the raw data. Usually they're using, but first we have to convert our data into that score and all, and after that we can use. So remember, both type estimates serve different purpose and provide valuable insights in various scenarios. Next, we come to the what could be the full form? I had already reported in my paper, AV, average variance extracted. That is means AV quantifies the proportion of variance captured by a construct relative to the variance due to measurement error. It tells us on average how much variation in the terms can be attributed to the construct itself. मतलब कितना percent हमारे इसमें जो variation आ रहा है and how much is going to the in the error term. And further is GFI, goodness of it, जितना अच्छा होगा, that means उतना अच्छा आपका model होगा. And further is AGFI, goodness of it index, GFI. These all are the good indices. And here's the RMSEA, that is the root mean square deviation or the root mean square error. Anyone you can take it. So in that way, this document also definitely I would share with you, right? And what is the purpose? Now, the next question arises. What is the purpose of the CFA? CFA is employed to assess whether the observed data align with the hypothesized measurement model. And this model is based on the theory of the previous research. So that means your constructs are valid. That would check the validity of the constructs and relationship, right? Whatever the survey items you had collected, model fit values also, right? And further is all these things we had already given you, right? Further is interpretation. Yes, of course, interpretation. I had already given you that table. The next question is, when we are using regression, what is the meaning of the R squared? What is the meaning of the adjusted R squared? So R squared means we are talking about measures the proportion of the variance in the dependent variable, the one we are trying to predict. That is explained by the independent variables in the model. The range would be R square 0 and 1. So interpretation, what we can say an R squared value of the 0 indicate that the model does not explain any variability in the dependent variable. So while we are taking into consideration that variable, we must drop that variable because that is not affecting at all our dependent. Right. So R squared value of 1 means the model explains all the variability. Higher R squared value suggests a better fit, but it does not necessarily mean the model is a good predictor in our absolute sense. But why people are saying number of times why adjusted R squared, it is much more important as comparatively to the R squared, because see, difference is adjusted R squared, that is the address a limitation of the R squared, especially in multiple regression, because that would report only suppose you had add on one variable, right? And it is not impacting on your model. So it will not consider, right? It will not consider, but R squared value that would be increased. But that would be adjusted R squared, that would be addition of unnecessary, penalized the addition of the unnecessary variables. While R squared tend to increase as more variables are added to the model if they do not significantly improve the model. But adjusted R squared penalizes the addition of the unnecessary variable. It considers the number of the predictors in the model and adjusted R squared accordingly. Right? So that is why that's very important. So R squared will stay the same or increase when this is the main role of the R square. Let me give another color of this. Right. R square will stay the same or increase when adding more predictors, even if they are not contributing meaningfully. This can give a falsely optimistic view of the model's performance, but adjusted R square is more conservative and will decrease if additional variables do not contribute significantly to the model's explanatory power. Right? You understand? Let's say you had added one variable and that is your adjusted R square is decreased. So that means you should understand this particular variable that you had added in your study, that is not giving any significant impact, so that you must drop it. And moment you will drop it, that your adjusted R square will be increased. Right. But R squared, whether you are not, I mean, that particular variable you had added, whether it is contributing significantly or not, but that will increase. So that is why I could say the adjusted R square, that is always important as comparatively to the funds. So that's all not clear what happened. I think, am I audible?
Yes, ma'am.
Right, right.
Yes,
So
ma'am,
I
you're
think,
audible.
yes. I think that problem from some other, I think those are trending, might be internet problem from that side. Right. So if you have any question, you can ask me, and I could be able to to answer all these questions. And I'm sure after book I will share. That book I have already shown you, multivariate. That one is the analysis. I will share you. Yeah. Ma'am, can we, yes, this is a good question. Ma'am, can we use different Likert scale for variable of items for single study? See, no, because I think you must use, because see, we are working on these numbers, right? How it would find out construct validity. This one is the discriminant validity and all. So you must use the same Likert scale for all the variables, those you are measuring. That's important. Next one is, what if one has less than 3 latent variable for a construct? Yes, of course. That's a good question. Actually, if you have, let's say, only one item or two items, it would not calculate. It will not give you an exact picture, because otherwise some statistician, they are saying two or all. I mean, if you have two or more than two, that is good. That can be possible. It can be possible. You can get your results. But I have already gone through Professor Hare's book, and in this book, specifically, that is written, you must have more than two, right? That then only your results would be up to the mark. Right. So, any other question?
Ma'am, I have a question.
Yeah.
I mean, when you did the CFA, you spoke about the correlation and it said it should not be more than 0.7 or 0.6.
Hmm. Which correlation? Sorry.
Ma'am, when you drew the diagram, the CFA
Hmm.
diagram.
Hmm. Hmm. Hmm.
Yeah, so when you were correlating the various factors,
Hmm.
you, when the result came out, you said this should not be more than 0.6 or 0.7.
No,
What was
not 0.5. I could say 0.5.
value? Okay, okay.
Right.
And
Because
yes,
justification is this. See, whenever you are doing correlation is moving from 0 to 1, right? 0 to 1. So if you're leading towards the one side, means point, it would be greater than 0.5. So ultimately, we can say these two constructs have a strong correlation. When you have 0.9, 0.8, that means that there would be strong correlation. So that means there is the multipolarity issue would be developed. So ultimately, people, your reviewer or whosoever is checking your paper, they would say, ki, why you can merge? Why not you can merge both these constructs into one? Because they are highly correlated. So here is correlation should always be less than 0.5,
okay. And
right?
with regards to regression, you spoke about values need to be less than what, ma'am?
Which one is
Ma'am, if you can go to that.
regression weight? Regression weight. Yes, of course.
Yeah.
I
So
said
that,
ki there should be regression weight. It should be 1. Right, because that means we want to find out there is any relationship is exists. That is why until unless you are not defining regression weight on the arrows, so it will not work.
no, ma'am, that is when you
Yeah,
put it at one. But when the
right.
result comes out, you spoke about some value for that also, na? Needs to be less than something.
Okay, fine. Yeah. Those are the items, those are correlated with the construct. So these values should be greater than 0.6. Should be greater, because we can say these values if not greater than 0.6, so means we can say these items are not able to define your constraint. Means you have not taken a correct scale to measure your research problem,
Got it, ma'am. Last
right?
question.
Yeah.
Ma'am, if suppose that funnel lacquer is a method which you use, and
Hmm.
in that case, what you use with Stats Wiki is
Hmm.
showing that you have discriminant validity. I have
Yes.
then gone ahead and then done it through the HTMT method, and which showed
Right.
that I didn't have. So then HTMT method is a better method because it's less than 0.9. I got.
Yes, 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 of course. Yes, of course. And that is why when we are writing a research paper, so we are defining for Lacquer method we had used or HTMT method we had used. So here is clearly you can define which particular method you will use. If you have got one, that is good. No problem.
Thank you.
Right. And next is, I think one more question is, will using a 5-point scale instead of a 7-point scale impact the output? No. Because, see, what happened earlier, people were using even 9-point scale also. So at that time, somebody had raised this question, 9-point scale, that is giving more confusion to the respondent. So see, somewhere else we are saying strongly agree, right, moderate agree, then agree, right, and neutral, and again disagree, then moderate disagree, and strongly disagree. So here is, that is all right. So that is why generally people they prefer 7-point scale rather than as comparatively to the 5-point scale or 9. So that is giving more clarity. You can use, doesn't matter, you can either you are using 5-point scale, because I have done some research papers on the 5-point Likert scale, and some I have used on 7-point Likert scale. I like this paper is I have used 7-point Likert scale. So that is all right. There is the one important question. In this case, merging the variables and constructs can be done. Yes, of course. Yes, that is why we are doing this CFA. And that is why, if suppose somebody will ask me through the Strats Wiki, if your values are AB and all these things, these are coming in the red color. So how you can resolve this issue? Yes, of course, because there's the high correlation, and also you can merge both these constructs into a one, or you can start dropping some items. Let's say you have 7 items in a one single construct. So drop that item that is the very weakly correlated with your construct. So you can drop that item, then again you can run hit and trial again and again. You can do that, and because what, because then after that you can reach on the that kind of result that you desired, and that is validated result. You can find it, right? Next question is, I'm sure I could be able to answer your query. Next is it advisable to run CFA and SEM with standardized Z score instead of the? Yes, of course, because I had collected once a data, and that was not running properly. I mean, that is not giving proper results. So what I did, I had converted my data into Z score, right, standardized Z score, and after that I have run, so my results has been improved. So if somebody is facing this kind of issue, you are not getting CFA and SEM up to the mark, so what you have to do, you people can convert your raw data into Z score, Z score, and after that you can run CFA and SEM. That could be advisable. Yes, we can do that. Any
Ma'am,
other query? Yeah.
Ma'am, mediation and moderation, what would you, guide us to read if we are looking at mediation and moderation to be performed in SEM?
Yes. Mediation, see, mediation and moderation, these are entirely different things, right? I am just sharing my this document. I just want to show you, like you had raised a good question. I just want to show you. This is my file. And I had already given, because you will attend that session also, mediation and moderation. I just want to, because process macro also one of the way. Uh, yes, I just want to show you number of the models are available right? These things already templates has been given. I will share with you these templates also. These are the templates, and these templates that will tell you which kind of moderation or mediation you are going to use. This is the model one. Here is, you can see X and Y, and this one is the moderator, right? This one is that is the statistical diagram of this, and this is the conceptual diagram. Same with model 2, there are n number of models you can see. So you can use with the help of this. I just want to show you. This text file also I will share with you. So you can model it and number of models. So we can mention all these things. We have used this model. This one is the model number. You can see it's model 74. So total there is in this text, there are 74 models, right? Introduction to Mediation Moderation and Conditional Process Analysis by Professor Hayes. Andrew F. Hayes ने already ये 74 models दिए हैं. You can use these models in your study. Either mediation through mediation or moderation we can use. Right. You were asking mediation and moderation. Moderation means your study, let's say, gender-wise study, you can moderate your study gender-wise, age-wise, you can do that. But mediation, yes, you are talking about that would be in between two variables, whether there is the partial mediation or full mediation, right? If you are going through, so your model is improved or it is going towards the worst side. So you can check, and after that you can report whether this particular, if I'm going through this, that is the partial mediation and there is the full mediation. So that means it is showing you ki, I mean, this factor, when you are using this mediation, this factor, it is not useful. You have to use, because full mediation is there. So this factor is influencing this process, right? So you can say that.
Okay, thank you.
And yes, thank you. Anything else? No. Sure. I think that's all from my side.
Yeah, I think the queries, you have answered all the queries, madam. Thank you so much. Any queries from the participants? From the chat box, I think we have answered all the queries.
Yes.
Okay, reshared the feedback form. Yes, we have reshared the feedback form. But before we close, let me thank Dr. Ashulekha Gupta, on behalf of all participants. Thank you so much, ma'am. These 2 days, you have taken us through all these, relationships, how you can explore and, handle the data. So yesterday's research inputs, what you gave, the practical application per se, how and where it stands. And today, why you need to start with the thing and how you can handle the thing. It's wonderful, wonderful session. In continuation with the regression topic, what we had the day prior to that particular thing, factor analysis, CFA, making the model, I think with little bit of practice on the data, it is possible for all the researchers to explore it further. Just one question, ma'am. Would you be sharing this data file that you have, worked on, during this session?
Ma'am, data file, because I will share, no problem. I will share
So
that. data
maybe if it is your working paper, probably,
Hmm.
certain dummy variables or the thing, if you can add, it will be good.
Right,
But at
right,
least,
right.
by looking at your video, if people can practice, that will be much
Right.
more easier for them.
Correct, ma'am, correct.
Yeah,
I will do
thank you
that.
so much. Thank you so much. This video will be available to all the participants, and whatever resources ma'am has already shared, those will be available. Guys, please understand, here et al is the Bible for researchers. The Gaskin, these stat wikis, whatever madam has shared, those details, they are the wonderful things. We need those things throughout our life. So happy researching. Thank you so much, madam, for these wonderful sessions. You were really, really fab. Thank you so much.
Thank you so much, ma'am. Thanks a lot.
Thank
Thank
you.
you. Thank you very much.
And participants, yeah, on Monday, we will meet again. So on Saturday, Sunday, happy researching. Thank you so much. Please fill up the form, feedback form. And on Monday at 2 p.m., as usual, Let's meet again. Thank you so much.